For decades, the mantra in the software world was pretty simple. One database to rule them all. And hey, for a long time, that worked just fine. But the kinds of applications we're building today, they're global, they're instant, they're hungry for data, they're just different. And that old mantra, it's really starting to break under the strain. So let's dive into a much more powerful, more specialized approach.
I mean, just think about the apps you use every single day. They've got to serve millions of people all across the planet with absolutely zero delay. They process your payments, they remember what's in your shopping cart, and they give you those spooky good personalized recommendations. So, can a single one-size-fits-all database really be great at all of those completely different jobs? The short answer is a hard no.
And that brings us to this really core idea, polyglot persistence. Now, polyglot sounds kind of fancy, but it just means knowing multiple languages. So in our world, it means our application can speak to multiple different types of databases. It's exactly like a carpenter's toolkit, right? You wouldn't use a hammer to turn a bolt. You'd grab a wrench. It's all about picking the absolute best, most perfect tool for each specific task you have.
Okay, to really make this idea click, let's actually build out a simple e-commerce application together, piece by piece. I think this is the best way to see not just what polyglot persistence is, but really get into the why. Why it's become so incredibly important for building any kind of powerful modern app. Okay, first things first. If we're going to be selling stuff, we have to handle money. This is the bedrock of the entire business. Every single order, every transaction has to be processed with 100% accuracy. There is absolutely zero room for error here.
So for this job, we need a classic, rock-solid relational database like Azure SQL. Why? Well, because it's literally built for transactions. It gives you guarantees of consistency. When a customer pays, the money is taken, the inventory gets updated, the order is confirmed, and it all happens as one single, unbreakable operation. This is our system of record. It has to be perfect.
Awesome. Our orders are handled. But what about the actual user experience? Our app has millions of users, right? They're in London, they're in Tokyo, they're everywhere. They're all browsing products, adding things to their carts, updating their profiles. All of that data needs to be available everywhere, all at once, and it has to feel incredibly fast.
And for this challenge, our trusty SQL database, well, it's not the best fit. We need a totally different tool for this job, something like Azure Cosmos DB. This thing is a globally distributed database designed for exactly this scenario, just massive scale and blazing fast performance anywhere on the planet. So all those user profiles, all that browsing history, the shopping carts, that's the kind of data Cosmos DB just eats for breakfast.
Okay, so our app is reliable and it's scalable, but does it feel fast? Every time a user loads a page, we really don't want to be hitting our main databases if we don't have to. For stuff that gets accessed constantly, like product details, sale prices, we need a shortcut.
And this is the perfect job for a cache, like Azure Cache for Redis. Now, this isn't a permanent database. Think of it more like a super fast, in-memory storage layer. It just keeps a copy of the most frequently used data right there next to the application. The result? It dramatically reduces response times and takes a ton of pressure off our other heavier databases.
So our app is humming along, but we are generating a mountain of incredibly valuable data. Every click, every purchase, every search query. The business side of the house wants to dig into this mountain and find some gold, to understand customer behavior, spot the next big trend, and just make smarter decisions for the future.
And for this, you guessed it, we need yet another specialized tool. You simply cannot run huge, complex analytical queries against your live production databases without slowing them to a crawl. That's what platforms like Azure Synapse Analytics are built for. They're designed differently. Instead of being fast at updating one little row at a time, they're optimized to scan massive columns of data at once, perfect for generating business intelligence without disrupting the app's day-to-day operations.
Okay, so we've got 4 different data technologies, each with a very clear, distinct purpose. I know it might sound complicated, but let's actually see how they all connect and work together to form one cohesive system. We'll follow the data from a single click all the way to a final business insight.
So let's follow the entire journey. It all starts with you, the customer, adding an item to your cart. That action instantly updates Cosmos DB. Then, when you go to check out, Azure SQL securely processes the payment. Now, behind the scenes, all of this activity data gets copied over into Azure Synapse. And finally, a business analyst can run a query against that data to discover that, hey, blue sweaters are the hottest item this week in Germany. See? 1 click, 4 systems, 1 super valuable insight.
Now, this is an incredibly powerful way to build software. But, and this is a big but, it is not a free lunch. Adding more specialized tools to your architecture also means you're adding complexity, and that's a trade-off we absolutely have to talk about.
The trade-off here is pretty clear. On one hand, the power you get is amazing. You get optimized performance, you get massive scalability, because you're using the best tool for every single job. But on the other hand, the price you pay is real. Your team now has to operate, monitor, and secure multiple different systems. You need really strong data governance to keep track of where everything is. And you're probably going to need engineers with specialized skills for each of those databases.
So this brings us to the ultimate question for any architect or developer out there. When is all that power actually worth the price? How do you make that call? When to stick with what you already have versus adding another new piece to the puzzle? Well, this simple rubric can help guide that decision. You've got to ask yourself, first, does my data actually fit the existing model, or am I trying to force a square peg into a round hole? Second, can my current database handle the scale I need, or do I need something that's globally distributed? Next, does my team already know this technology inside and out? And finally, the big one. Is the benefit I'm getting so huge that it truly justifies the cost of adding and managing another system?
And at the end of the day, it all comes down to this. This is the golden rule. The goal is never to use as many cool technologies as possible or to build the most complex system. The goal is elegant simplicity. It's all about using the fewest tools necessary to do the job right and build a great application.
So I'll leave you with this thought to take back to your own work. Take a look at the challenges you're facing, the kind of data you're handling, and the experience you're trying to build. Is there a problem that could be solved so much more elegantly with a different kind of tool? What's the next right tool that can unlock a whole new level of performance or capability for your project? That's the core question of modern architecture. Thanks so much for joining this explainer.